Hello, today our topic is about the data warehousing and the data mining. So let's start with the introduction to the data warehousing. It is a centralized repository that stores the integrated data from multiple sources. It is specifically designed for the query analysis and reporting rather than the transactional processing. It serves as the analytical backbone for business intelligence systems, turning raw transactional data into the actionable insights. The characteristics of the data warehousing are the subject-oriented, non-volatile, time-variant, integrated. Firstly, the subject-oriented. It is optimized to provide the information around a specific subject, example, the sales, customers' revenue, rather than ongoing operations. Integrated. Data from different sources is combined and standardized. Time variant. Data is identified with a specific time period. It keeps historic records to analyze the trends over the time. Non-volatile. Once the data is loaded into the warehouse, it is read-only and cannot be updated or deleted by the users. New data is appended periodically. According to the William H. Inman, the father of data warehousing, a data warehouse has the four core characteristics which I have stated now. They are the subject-oriented, integrated, time-variant, and the non-volatile. The features are the separation from operational database, data summarization, metadata repository, OLAP optimized. Next, here comes the topic about the OLAP. The OLAP stands for the Online Analytical Processing. It is a category of software technology that enables the analysts and managers to conduct interactive, rapid, and multi-dimensional evaluations of large data sets. It uses a data structure called an OLAP cube to allow the operations like the drill down, roll up, slice, dice, and pivot. There are many types of OLAPs. They are the ROLAP, MOLAP, HOLAP. ROLAP stands for the Relational Online Analytical Processing. It works directly with the relational databases. It does not pre-compute the cubes. Instead, it generates the complex SQL queries dynamically to fetch data directly from the star or snowflake schemas. The example is given. Please note it down. Next, there comes the MOLAP. It stands for the Multi-Dimensional Online Analytical Processing. MOLAP stores data in the optimized MOLAP stores data in the optimized proprietary multi-dimensional arrays, the cubes, rather than relational tables. All the calculations are pre-computed during the cube loading stage, ensuring lightning fast query execution times. HOLAP. It stands for the Hybrid Online Analytical Processing. It combines both the ROLAP and MOLAP traits. It stores high-level aggregated summary records in a fast, multi-dimensional cube, while leaving granular, atomic records inside a relational database. ROLAP approach. Next, there comes the schemas, data warehouse schemas. Introduction. A schema defines the structural layout of the tables, relationships, and views inside a database. In data warehousing, schemas are specifically designed to minimize the complex joins and speed up massive analytical read operations. They break data down into the fact tables. They can be stated as the metrics or measures, and dimension tables. They can be stated as the context attributes. There are types of schemas. They are the star schema, snowflake schema, fact constellation schema. See, for the star schema, it is the simplest layout style where a single central fact table is directly linked to the multiple surrounding dimension tables. It resembles a star shape. Dimension tables are completely denormalized, meaning data redundancy is intentionally accepted to achieve fewer table joins. See, normalized, that means the tables can be added more. The denormalized is the quite opposite to the normalized. See here we have provided you a diagram. Can clearly see here. This is the dimension table. It is being normalized. It is the fact table. You can clearly see. Next, the example is the retail sales database where the fact sales tracks total revenues directly joined to flat table slide dimension customers, dimension product. Next, there comes the snowflake schema. It is a variation of the star schema where the dimension tables are broken down further into normalized subdimension tables. This reduces the redundancy and saves storage space, but adds processing complexity due to the higher number of required table joins. Next, you can clearly see here the diagram. Please note down the diagram. Next, there comes the fact constellation schema. The fact constellation schema can also be said as the galaxy schema. It contains multiple central fact tables that share a common set of dimension tables. It acts like a network of the interconnected star schemas. The next topic is about the data mining. Its introduction. The data mining is the computational process of uncovering the hidden, valid, novel, and potentially actionable patterns, anomalies, and correlations within massive datasets. It relies heavily on the intersectional techniques from machine learning, statistics, and database systems to convert the raw inputs into the structural knowledge. The characteristics of the data mining are the large datasets, pattern discovery, predictive capacity. The large datasets. It operates on massive volumes of structured or unstructured data. Pattern discovery automatically extracts implicit previous unrecorded patterns. Predictive capacity. It creates reliable mathematical models to anticipate the future behaviors. These three are the main characteristics of the data mining. The data mining mainly focuses and it is used for the large datasets. They may be of the structured, unstructured, or semi-structured to identifying the patterns, similar patterns to predict the things and vice versa and many more. The features of the data mining are the automated exploration, which uses the algorithms to scan the data with minimal manual guidance. Actionable results. It delivers the insights that directly drive real-world business decisions. Multi-algorithmic framework. It employs diverse techniques like the neural networks, decision trees, and clustering dependency on the data sheet. Types of data mining. Predictive data mining. It analyzes the historical data to build models that forecast unknown or future values of a target variable. Example, scoring credit applications to predict if an applicant will default on a loan based on past payment behavior. Descriptive data mining. It uncovers the hidden relationships or underlying structures within the historical data to summarize its primary traits without forecasting specific target values. Example, grouping e-commerce clients together based on the shared purchase habits, understand the customer segments. Next, there comes the KDD process or the KDD life cycle. The KDD stands for the knowledge discovery in databases. It is the iterative, multi-step overarching process of turning the raw data into the useful knowledge. It is the vital to note that data mining is merely one distinct step within the broader KDD lifecycle. Here we have provided the sequential steps of the KDD process. Please note it down and it can be helpful for the clear understanding purpose also. See, first the raw data transformation knowledge. First the cleaning and integration takes place for the target data. Next, selection and transformation phase. The third one, data mining step, and pattern recognition, and the last one, evaluation and presentation of the knowledge. First one, the data cleaning. The data cleaning refers to the noisy outliers, errors, and incomplete values which are handled and removed. As we all know that the data is aggregated or brought or come from multiple sources from different methods or methodologies. Firstly, the data is cleaned in the data cleaning phase. It removes the noise, outliers, errors, and incomplete values. Next, it comes to the data integration, where the multiple heterogeneous data sources are merged into a unified repository. Next, there comes the data selection. Here, the data is relevant to the specific analysis goal is retrieved from the database collection. See, after the completion of the data integration, the data is selected, which is the good or which is efficient, which is valuable, and which is good to be taken for that process. At this stage, at the data transformation stage, the data is consolidated. It is transformed into the required or the desired format suited for mining via the consolidation operations like the normalization, aggregation, or feature scaling. Next, there comes the data mining. It is an essential step where the intelligent algorithmic models are applied to extract the hidden patterns. Pattern evaluation. It identifies a truly interesting, novel, and valid patterns based on the clear evaluation metrics such as accuracy or support confidence thresholds. Here, it is just a algorithmic formula support confidence. The knowledge presentation stage. The visualization techniques like the charts, dashboards, reports are used to share the discovered knowledge with business decision makers. The mining techniques and the clusterings. Various data mining techniques are the classification, which assigns items in a collection to target categories or the classes like the filtering email into the spam and versus non-spam. We often get the mails. Regression. It models relationships between the variables to predict the continuous numerical values. Association rule mining. It finds the hidden if-then relationships between the frequently co-occurring items. Clustering. It groups similar data objects together without using predefined class labels. Anomaly detection. It identifies unusual observations that deviate significantly from standard patterns. Introduction to the clustering algorithms. The clustering is an unsupervised learning method that segments a data set into groups, clusters. The objective is to maximize the intra-cluster similarity. That means the items in the same group are very alike and minimizes the inter-cluster similarity. Items in different groups are distinctly different. Types of clustering. Partitioning methods. Constructs k distinct data partitions where each item belongs to exactly one cluster. The groups are refined iteratively by shifting items based on the distance to cluster centers. Examples are the k-means or k-midpoints partitioning. List of corporate clients into 3 distinct spending tiers. Hierarchical methods. Creates a hierarchical decomposition of the data set. Can be agglomerative, bottom-up merging small groups, or divisive, top-down splitting large groups, forming a tree structure called a dendrogram. Now, where I said the agglomerative and the divisive clustering, these two comes under the clustering algorithms under these two, or the clustering algorithms. Example, building an evolutionary biological family tree, grouping animal species based on DNA sequence traits. Next, there comes advanced partitioning, k-midpoints and palm. Introduction to the k-midpoint algorithm. The k-midpoint algorithm is a partitioning clustering technique closely related to the k-means. While k-means computes clusters center using its mathematical average, a centroid, which may not match any real data point. K-midpoints always selects an actual physical data point from the dataset to serve as the cluster center known as a middoid. The key advantage is it is significantly more robust to noise and outliers than the k-means because extreme outliers values do not skew an actual point's location the way they distort a calculated mean. The PALM, it stands for the partitioning around middoids algorithm. It is the foundational implementation of the k-middoid clustering approach. It operates by iteratively evaluating swaps between the current middoids and the non-middoid points to reduce the overall distance errors across all the clusters. Here, step-by-step PALM execution workflow is given. First, the initialization. It randomly chooses the k actual data points from the given dataset to serve as the initial target middoids. The assignment. It maps every remaining data point to its closest middoid using a distance metric. They are the Manhattan and the Euclidean. There are two distinct formulas which is given for the distance by the Manhattan and the Euclidean. The cost computation. It calculates the total cost S, which is the sum of all absolute distances between points and their assigned middoids. Swap evaluation. It selects a non-middoid point H and temporarily swap it with the current middoid M. It recomputes the total cost. Selection. If the new total cost is lower, keep the swap permanent. If the cost increases, undo the swap. Loop termination. Repeat the steps 3 to 5. That means 3, 4, 5 steps until middoid assignment stabilize and the cost can no longer be reduced. The PALM calculation example is given here. Given a 1D dataset, one-dimensional dataset with k equals to 1. If k-means is used, the center is calculated as the mean 27.25, which sits far from all actual points due to the outlier 100. If PALM is used, PAM, it evaluates the actual data points and selects 3 or 4 as the middoid, effectively isolating the outlier 100 into its own context. Frequent item set mining or the a priori mining. The first one, a priori. The a priori algorithm is a classic algorithm used for finding frequent item sets and mining association rules in the transactional databases. It operates on the core a priori downward closure property. All non-empty subsets of a frequent item set must also be frequent. Conversely, if an item set is infrequent, all of its supersets or the subsets will also be infrequent and can be pruned immediately. Okay. Now we are saying about the a priori algorithm. Here's a clear explanation about the a priori algorithm in a step-by-step procedure. We have provided you an example. Consider the database with a minimum support count of 2. These are the transactions which are given here. Note them down. Execution step flow. In step 1, scan the DB database to generate the candidate 1 item set C1 and calculate the support counts. Bread. See here we have taken the bread, milk, diaper, don't mind. Here we have used some other words. Okay, like beer. Okay, bread, milk, diaper, beer. See here are 4 transactions. Among them, first we are scanning the database to generate the candidate 1 item sets C1 and calculate the support counts. Bread here we got 3 times 1, 2, 3. T1, T3, T1, T2, T4. Milk 3 times T1, T3, T4. And next beer 3 times T2, T3, T4. All item sets meet the minimum support count of 2, so they all move into the frequent 1 item set list L1. See, Note it down. The first one, the minimum support count is 3. We have taken here 3. Sorry, is of 2. If the minimum support count is 2, the given content in the transactions may be equal to or greater than to that support count, then it is okay. Remember this point, okay? The step 2, join L1 with itself to create candidate 2 item sets. C2, bread milk, bread diaper, bread beer, milk diaper, milk beer, diaper beer. See, I can explain you. First one, see in the T1 we are having the bread and milk. Note it down first. Bread and milk. We are again coming to the first one, bread milk. Next, bread diaper. Next, bread beer. Next, milk. We got here milk, diaper, milk, beer. Like that we are arranging here. C2 items. Step 3. Scan database to calculate the support counts for C2 items. You can clearly see I said you there the minimum support count is 2. All pairs meet the support threshold of 2, creating frequent 2 item sets. L2. Step 4. Join L2 to generate the candidate 3 item set C3. Bread diaper beer, milk diaper beer, etc. Prune combinations whose subsets are infrequent. Then verify counts by scanning the database to find that final frequent 3 item sets. Frequent item set mining. FP growth. The introduction about FP tree growth algorithm. It stands for the frequent pattern growth algorithm. Is an advanced frequent item set mining method which is designed to address the efficiency issues in the a priori algorithm. A priori requires repeatedly scanning the database and generating massive number of candidate item sets, which degrades the performance. Instead, FP growth uses a compressed data structure called an FP tree, frequent pattern tree. It retains item relationship records and mines frequent patterns directly from the tree structure, requiring only two database scans and completely eliminating candidate generation. Clear explanation by step. For an example, using the same transaction with the minimum support count to you said before. First step, calculate the support count for individual items. Sort items in descending order of frequency to create a header list. Scan 2. Construct the FP tree, read transactions one by one, sorting items by frequency and insert them into the tree as paths. Overlapping items, share common prefix nodes, incrementing node counts. You can clearly see here, mining the tree. For each item, trace its prefix paths to find its conditional pattern base. Build a conditional FP tree and extract frequent item sets. For milk, paths are diaper, beer, bread, beer, diaper, bread. Summing occurrences yields frequent combinations like diaper, beer, milk without generating candidate sets. Without generating the candidate set. Next, here comes the bidirectional mining, that is the pincer search algorithm. The pincer search algorithm is an advanced frequent item set mining technique designed to quickly discover the maximal frequent item sets, MFI, which the a priori algorithm works strictly bottom up, finding frequent 1 item sets, then 2 item sets, and so on. Pincer search uses a bidirectional search strategy. It searches bottom up to find the frequent item sets while simultaneously searching top down using a data structure called the maximum frequent candidate sets, MFCS, to identify large frequent item sets early. Here's an example which you have provided you. Suppose a database contains items A, B, C, D, E and a very long frequent item sets like A, B, C, D exists. How a priori handles this? A priori must complete 4 full database scans generating candidates at every level, first finding individual items, then pairs, then triplets, before finally discovering the full 4-item combination. How pincer search handles this? Bottom up direction, first one. Scan small item sets like A, B, C, D in parallel with the top down pass. Top down direction starts by testing the largest possible item sets, MFCS, A, B, C, D, E. Pruning step. If a database scan reveals that the combination A, B, C, D, E is infrequent but the sub combination A, B, C, D is frequent, this 4-item set is immediately added to the frequent list. Early termination. Early termination. Once a large item set is confirmed as frequent, the bottom-up search can skip testing any of its smaller subsets. Skip any of its smaller subsets such as AB, AC or BCD. This significantly reduces the total number of databases scans and candidate item sets generated. Next, there comes the scaling up clustering, the Clara and Clarence. Introduction to the large scale clustering. The traditional PALM K-Midioids algorithm scales poorly on large datasets because evaluating cost swaps across every point requires heavy computation. To handle massive datasets efficiently, optimized variations like Clara and Clarence were developed. The Clara stands for the Clustering Large Applications. Clara improves scalability by applying PALM to a random sample of the dataset rather than the entire dataset. It draws multiple independent random samples, finds the best midioids within those samples using PALM, and then evaluates those midioids against the entire dataset to choose the best overall fit. The example, if a dataset contains 1 lakh customer profiles, Clara extracts 5 independent random samples of 400 profiles each, runs PALM on those small samples and applies the best performing midioid set to the full population. The Clarence, it stands for the Clustering Large Applications based on randomized search. Unlike the Clara, which restricts its search to a fixed sample at the start, Clarence treats the search for optimal midioids as a graph exploration problem, where each node represents a set of k midioids. It dynamically samples a subset of neighbors during each step of the optimization process, without locking itself into a single fixed sample. This approach provides a better balance than Clara, avoiding localized sample bias while remaining much faster than running PALM on the entire dataset. Example, used in spatial geographic information systems (GIS) to cluster millions of coordinates into distinct regional zones without encountering memory or processing bottlenecks. The scalable decision trees, the rainforest. Interaction. Rainforest algorithm is an optimization framework designed to scale decision trees classifiers to massive datasets that are too large to fit into a computer's main memory, that is RAM. Standard decision tree algorithms like ID3 or C4.5 require loading the entire dataset into memory to evaluate the splitting criteria at each node, which causes the system crashes when working with large datasets. Rainforest solves this by extracting and maintaining compact aggregated statistical summaries of the attributes rather than loading the raw data rows. Clear explanation with an example concept. The core innovation of the rainforest is the ABC set, which stands for the attribute value class set structure. For each attribute at a decision tree node, it builds a compact summary table tracking distribution of target class. Example dataset concept. Predict if a customer will buy a product based on age, youth or old. How rainforest compacts this? Instead of reading all rows repeatedly, rainforest builds a single compact ABC set table for the age attribute. resulting efficiency. The algorithm can calculate splitting metrics like Gini index or information gain directly from this small summary table. It constructs the full decision tree efficiently while keeping memory usage proportional to the size of the attributes rather than the total number of data rows. Next, there comes the text and web mining. Introduction to the text mining. It is the process of extracting high quality, non-trivial insights and structured information from unstructured natural language text documents. Types and examples of text mining. Sentiment analysis, evaluating text to identify the underlying emotional tone. Example, scanning restaurant reviews to classify them as positive, negative, or neutral. Text classification or categorization automatically assigns documents to predefined topic buckets. Example, routing incoming customer support emails to specific departments like the billing, tech support. Entity extraction. It identifies the key terms like the names, locations, dates, or product codes within the raw text. Examples, scanning medical charts to extract patient symptoms and medication names. Introduction to the next topic is about the web mining. It applies data mining techniques to automatically discover and extract patterns directly from World Wide Web, www resources, hyperlinks, and server logs. Types and examples. Web context mining. Mining text, images, and information contained within the web pages. Example, scraping e-commerce websites to monitor the competitor product prices in real time. Web structure mining, analyzing the hyperlink connection network to evaluate authority and relationship of web pages. Example, Google's PageRank algorithm analyzing incoming backlinks to rank search results. Web usage mining, analyzing user navigation patterns and clickstream data recorded in web server logs. Example, Amazon tracking a user's click path to optimize website layout and item placements. The machine learning about the support vector machines. Support vector machine (SVM) is a powerful supervised machine learning algorithm primarily used for binary classification and regression tasks. The core objective of the SVM is to find an optimal decision boundary called a hyperplane that separates the data points of different classes with the maximum possible distance margin. The core concepts of SVM are hyperplane, a decision boundary that separates the data classes rendered as a line in the 2D space or a plane in 3D space. Support vectors, the data points located closest to the hyperplane. These critical points define the position and orientation of the boundary line. Removing them would alter the boundary itself. Margin, the perpendicular distance between the separating hyperplane and the closest support vector. SVM aims to maximize this margin to ensure robust classification. Kernel tree, a technique that maps non-linearly separable low-dimensional data into a higher dimensional space, where it becomes linearly separable. A clear explanation with a linear example, which is provided here. Can please note it down. That's all about today's class. See, I want to give an extra information about today's topic about the data mining and data warehousing. The few important questions which can be given in your examination point of view are the support vector machine, rainforest algorithm, Clara and Clarence, the features of the data mining and data warehousing. Today I also wanna provide you some Viva questions which will be often asked in your Viva. They are the full form of ETL, characteristics of data mining and data warehousing. What is mean by hierarchical clustering? Types of hierarchical clustering. What are neural networks? What is web mining and text mining? Types of text mining. Types of web mining. What is the importance of neural networks? Explain k-metered algorithm. Explain k-means algorithm. What are the classification techniques? What are the regression algorithms? Different clustering algorithms. Now, whatever I have said, these are some of the important Viva questions and also some of the key questions which will be asked in your examination point of view. Okay, thank you students. That's all for today's our class.